All right, let's do a hypothesis test with the Central Limit Theorem. Do college students watch less TV per day than all adults in the US? Now, I don't mention it there, but this has got to be something like averages or medians. And I'm going to go for average. So let's see, to answer this, I need to know about what all US adults watch. And I looked at a couple of different studies on this, and one of them, they all were pretty similar. The question that most of them struggle with is, what does it mean to watch TV? Because we have phones, we have things like Netflix and Snapchat and TikTok. So I'm generally thinking of things like that. It's not clear on some of these studies whether they included things like smartphone usage, like TikTok, Snapchat, video type things, or games. But again, based on questions I asked you all earlier, I would put that in there. And here they have for 2022 about 181.7 average minutes per day, which is just a hair over 3 hours. So I'm just going to call it 3 hours for simplicity here. And then I have some sample data that we'll throw in here to compare that to. So this statement right here, summarized mathematically, says mu is less than 3. And because that doesn't have an equal to in it, that's got to be the alternative hypothesis. And the 3 came from that one study and some other similar ones. And I would say that would be the null hypothesis in this case, that mu is 3. So those are my hypotheses. The less than means that eventually I'm going to have to do a left tail test here. I should set a significance level. I'm going to go with the standard 5% significance level. And what else? Central limit theorem tells me a couple of things. To do a hypothesis test, I need a standard error. And the standard error is approximately the sample standard deviation divided by the square root of the sample size. Based on that, we can calculate the test statistic, or the standardized test statistic, and that's going to be a t-score for a mean, and that's the sample statistic, the sample mean, minus the population parameter mu divided by that standard error, which is s over the square root of n. Based on that t-score, we can then calculate a p-value. And the new thing here, besides using the central limit theorem, is that if we're working with means, we should use a t-distribution for the p-value. And a t-distribution is similar to a normal. It's a little bit wider to take into account. Not only are we questioning the mean, but we also don't know what the population standard deviation is. So based on that further uncertainty about the situation, we have to widen the interval a little bit, and that's what the t-distribution does for us. So next thing we need to do is we need the sample information. So let's head over and get that. And links to these will be in the description of the video. So here I have, for my 2022 statistics students, their information here. And originally somebody had said they watched 10 hours per day. I think they meant per week. So I pulled that out in this version right here. And I'm going to take that data, copy it, and bring it over to that spreadsheet I shared with you earlier. And I want the tab that says HT hypothesis test mean with data. And I've already plugged my data in here. If yours isn't in there, then you would just delete whatever is here. Give yourself a header. And then paste in your information underneath. Okay, so you should set your null hypothesis first. So here's my null, or next, set my null hypothesis to 3. If the alternative wasn't set to be a less than, you should do that for your own benefit. Computer doesn't care, but this is just for me. So that's good. And I remind myself this is a left tail test, not a right tail or a two tail. The summary statistics appear here automatically when you plug in your data, and it says I have a sample of size 32 with a mean of 2.1753. You can get more or less decimals out of that. Let's go with 4. Oops, wrong way. And here's my sample standard deviation. You have to enter your alpha in here, whatever it happens to be. And again, that's for reference. And then the computer automatically calculates your standard error. And it's going to take my sample standard deviation here and divide by the square root of the sample size for me. Based on that, it's going to calculate my t-score here, which says first subtract the sample mean with the population mean population parameter and divide by the standard error. And I get negative 4.499. And again, think about our 95% rule from way back. Expect about 95% of the data to be within 2 standard deviations left to right. This is 4.5 standard deviations below average. Ooh, that's below average. Left tail test, I get a p-value of about 0.00004-ish. Oh my gosh, that's small. All right, let's summarize this here in our notes. Make the right decision. So what do we got? We have a standard error. Actually, let's write down all of the sample data. So from the sample, we have n is 32. We have the sample mean is about 2.1753. Sample standard deviation is about 1.0367. And those are both hours per day of TV. And that's for the sample. For the sampling distribution, we get a standard deviation of S over the square root of n. Spreadsheet said that was about 0.1833 hours per day, and we get a t-score of about negative 4.4999. And that led to a p-value of about 0.12344-ish. Pretty small p-value. That p-value is definitely less than alpha, right? So if we compare them over here, it's always a good idea to write this down. 0.00004 is definitely less than. If p is low, the null must go. We should reject the null hypothesis is our decision. Then we have to come up with our conclusion. Before we do the conclusion, let's make a quick sketch. So I'm going to draw in here my best normal distribution. For a hypothesis test, it's always what the belief for the population is, and the belief is 3. Then the question is, how far from 3 does 2.17 fall? Does it fall near 3, just a little bit away, or does it fall far away? According to this t-score right here, it falls way out here. So this is my mean x bar of 2.1753. This was mu there. And the p-value is the probability of getting another similar sample that's lower, that has a lower mean than 2.1753. So that's my p-value, 0.00004, wicked small p-value. Reject the null hypothesis. That's what we got there. What is my conclusion? Well, the data supports the alternative. So I can say there is sufficient evidence that college students in the US watch significantly less than 3 hours of TV per day. That would be my conclusion here. And I'm just going to back this up with a t-distribution from StatKey. So StatKey homepage theoretical t-distribution is for means. And degrees of freedom, remember that's the sample size minus 1. So we had a sample of size 32. I enter 31. And then I enter my t-score for a left tail test. So left tail, my t-score, according to the spreadsheet, was negative 4.4999-ish. Okay. And StatKey theoretical t says you should get a p-value of about 0.000045, which is pretty much what the spreadsheet told me. Hope this was helpful. Have a good day. Do good math. Bye-bye.